Let's look at some applications of trigonometry. We'll start today with the law of sines. What exactly is that? Do we get in trouble if we violate the law of sines? I don't know. Let's take a look at an oblique triangle. That's a triangle that's not a right triangle. So it could be acute, it could be obtuse. So what I'd like to do is, in this triangle, let's draw a perpendicular from B down to side B. And by the way, let me make an arrow to point to things. What we're going to do is we're going to label our triangles. The angles will be capital letters, so angle A, angle B, angle C. And then the side across from that angle we'll label with a lowercase matching letter. So if this is angle A, the side across from it is side A. Angle B, side B, angle C, side C. Okay. So what I'd like to do is drop an altitude from B down to side AC. And that's going to be a right angle. Let's mark a little right angle mark in here. All right, and let's call the height of that H. Now, from what we know about right triangles and SOHCAHTOA, let's write an expression here. So, what is the sine of angle A? Here's angle A. In that right triangle on the left, the sine of angle A is equal to opposite over hypotenuse, so H over C. In the other triangle, on the other side of it, let's find the sine of angle C. Sine of angle C is equal to the opposite, which is H again, over this time the hypotenuse is A. Now, if I solve both these equations for H, I'm going to wind up with C times the sine of A is equal to H, and A times the sine of C is equal to H. And therefore, I can say that C times the sine of A is equal to A times the sine of C. In rearranging this, I could divide both sides by A, and then divide both sides by C, and I'll get sine of A over A equals sine of C over side C. So we have a ratio now dealing with an angle and the side across from it. So the sine of angle A over the side across from angle A will always equal the sine of angle C divided by the side across from angle C. All right, what if we wanted to include B? It's feeling a little left out here. So let's make a different right triangle. Let's move these out of the way. And what if we drop an altitude from C to side AB? And we make a right angle there, so there's actually two right triangles. Let's call that altitude, how about H sub 2, since I already used an H. And now looking at these two triangles, what is, let's see if I can make some room for this. How about over here on the side? The sine of angle B is equal to H sub 2, which is the opposite, over the hypotenuse, which is A. And in the other right triangle next to it, the sine of angle A is equal to the opposite, which is also H sub 2, divided by the hypotenuse of that triangle, which is B. And if I solve these for H sub 2, multiply A to the other side, multiply B to the other side, I'm going to wind up getting A times the sine of angle B is equal to side B times the sine of angle A. And once again, I can divide. If I divide both sides by A and B, I'm going to get the sine of B over B equals the sine of A over A. And we already know the sine of A, where's my arrow? We already know that the sine of A over A equals sine of C over C. And now I have the sine of A over A is also equal to the sine of B over B. So therefore, all three of these ratios are equal. And so we have, in any oblique triangle, the sine of angle A over side A is equal to the sine of angle B over side B equals the sine of angle C over side C. And that's what we refer to as the law of sines. Now, I could also have made this triangle, let me erase some of this stuff here. I could have also made this triangle obtuse. And here, I'll just draw a quick one for you. Let's say I have a triangle obtuse that looks like this. And calling this A, this B, and this C. I could go through and follow the same procedures, except this time to draw an altitude from B to side AC, I have to extend side AC, but we'll wind up getting the same ratios equal to each other. So you can walk through that if you don't believe me, but it will work exactly the same way. So for any oblique, not right angles, triangle ABC with sides A, B, and C, the ratio of the side with the sine of the angle across from it is going to be equal for any of the sides and angles. And so there's two ways we can write this. You can have your sines of the angles on top of the fractions or on the bottom. And depending on what you're trying to solve for, one might be a little more convenient than the other. Now obviously we have three different ratios equal. So what's going to happen when we solve problems is we're going to want to pick any two of these if we know 3 out of the 4 values. So if we know angle A and side A, and let's disconnect these. If we know, let's say, angle A and side A, and maybe side C, but not angle C, then we're going to set those two equal to each other and solve that proportion. Or maybe we know the sine of B and the sine of C and side C, but we don't know side B. Then we would use those two. So we're going to work through some examples, and you'll see which two we want to use. Depends on what's given to us in the problem. All right, so let's look at some examples. In triangle ABC, the measure of angle A is 35, angle B is 50 degrees, side A is 16 feet. Find the remaining sides and angles. And by the way, this is what's referred to as solving the triangle. When you find the measures of all the sides and all the angles. So if the directions say solve the triangle, it's the same as this. We're finding all the lengths of the sides and the measures of the angles. So we need to start from scratch here, so let's draw ourselves a triangle. And let's label this triangle A, B, and C. Doesn't matter which way you label everything. Let's call that A. This is angle B. This is angle C. We should make C a little bigger. How about like that? So then side A will be across from angle A, side B is across from angle B, and side C across from angle C. So there's our picture. Now let's label what they give to us. They told us that angle A is 35 degrees, and angle B is 50 degrees, and side A is 16 feet. Do that in a different color. All right, so we need to find the missing angle C and sides B and C. Well, what do we want to do first? If they give you 2 of the 3 angles, it's really easy to find the third angle. So the measure of angle C will be 180 minus the 2 angles that we have, 35 plus 50. And so the measure of angle C is equal to 85, so that's 95 degrees. All the angles add up to 180 in a triangle. All right, so now we have all the angles. Let me fill that in. Let me write that actually in a different color. Now obviously my picture doesn't look at all correct because it looks like when I drew it, angle C is actually an acute angle like maybe 30 degrees. But that's okay. If you want to redraw it, if it helps you, go ahead and do that. But this will still work for us. All right, now let's find the sides. So I'm missing a side. So what I want to do is, and it'll work either way, but since I'm missing sides, I'm going to use my fractions my ratios this way, with the sides on top. It just makes it easier when you're solving the proportion. So what do I know? In this problem, I know side A was 16 feet. I know angle A. I know angle B, but I don't know side B. So that's the proportion that I'm going to use to solve this. So you pick and choose based on what you have. So what do we have? So I'm trying to find side B over the sine of angle B, which is 50 degrees, will equal a side that I do know, side A is 16, and the sine of angle A is 35. Now, if it helps to actually write out B over sine of B equals A over sine of A, and then plug in the values, by all means do that. So you have to figure out what works best for you. Therefore, now let's see, what do we need to do? To solve for B, there's one simple step to do here. All we need to do is multiply both sides by the sine of 50, which will cancel the sine of 50 on the left side, and then I'll have B equals. So, and I'm going to probably get a nice long decimal answer. So I'm going to grab my calculator. I don't know the sine of 50 or 35 off the top of my head. Let's make sure you're in degree mode. Check. So now I'm going to do 16 divided by the sine of 35 times the sine of 50. Order of operations will work on the calculator. So we get 21.368. Now there were no specifications here. So as a general rule for us, let's go ahead and round to 2 decimals. So 21.37. So 21.37, and this had units on this problem, and the sides were in feet. All right, now similarly, I'm going to need to figure out side C, so I'll set that up the same way. So I'll say C over the sine of angle C, which we figured out was 95, equals, and I'm going to use A again. I could use B, my answer for B, but I don't want to use a rounded answer because then that's going to cause a little bit more error for side C. So I usually try and stick with the numbers that they gave me originally, if possible, over the sine of angle A, which was 35. And once again, I'm going to go ahead and multiply both sides by the sine of 95, and that'll cancel the sine of 95 on the left here, and I'll just have C by itself. And I'm going to get C is equal to, grab the calculator. This time we're doing 16 divided by sine of 35 times sine of 95. That's almost exactly what I punched in. Clear. So I'm going to press second enter. Recall that, so I don't have to type it all in. Change that last angle to 95. And there you go. 27.7, if we round to the hundredths, 9. 27.79 feet. 27.79 feet. And now we have solved this triangle. We know the lengths of all the sides, and we know the measures of all the angles. All right, let's try another one. And by the way, it's probably a good idea to hit pause and you try and solve it, and then come back and check with my work. So this looks like pretty much the same setup, except they drew the picture for us. So the first thing I'm going to do is find the measure of the missing angle, in this case angle B. So I'm going to do 180 minus the 2 angles that they gave us, which were 25 and 87. So that's going to be the measure of angle B. That's 112, so 68 degrees. Okay, I'm going to fill that in. So now I have all 3 angles. Now I need to figure out the missing sides. I know side B, this is side B because it's across from angle B. So let's start with, I don't know, I guess let's start with side A. So A over the sine of angle A, which was 87 degrees, is equal to B, which is 10, over the sine of B, which we figured out was 68 degrees. So if I made a mistake in that calculation, obviously then this answer is going to be wrong. So you really want to be careful when you use previous answers. So if I multiply sine of 87 to the other side, we'll write out all the steps there, I'll get what A is equal to, and then I'll grab my calculator, and I'll be done. And if you grab the calculator and check 10 divided by sine of 68 times sine of 87, you're going to get 10.77. And there were no units on this problem, so it's just 10.77 units. So we found A, we have all the angles, we have 2 of the sides, we need one last side, and that would be side C. So C over the sine of angle C, which is 25 degrees, is equal to B, 10, over the sine of angle B, which was 68. Once again, you could use your answer for A, but I would try and store then the complete answer for A and use that in your calculation for the next one. So then I'm going to multiply both sides by sine of 25, and then that'll give me C by itself. And when you grab your calculator and punch that in, you should get C as approximately 4.56. And no units on that. Okay, so right now you're thinking, boy, this seems pretty easy. I can handle this. But notice, what have we had in both these problems? In this problem, they gave us 2 angles and the side between them. And you remember from geometry, side angle side was a way of proving 2 triangles congruent. In the previous example, we were given 2 angles and then the side not between them. We were given the angle, and then side A. But that was also a way of proving 2 triangles congruent. Ooh, on this one I said it wrong. Apologize. I'm looking at it and I'm saying the opposite. This one we were given 2 angles and the side between them. Angle, side, angle. And that was a way of proving triangles congruent. This one we had angle, angle, side. That was also a variation of the angle, side, angle. And that was another way of proving triangles congruent. Let's look at the next example. Let's solve this triangle. First, let's draw a nice picture for it. And let's call, doesn't matter, let's call this A, this B, and this C. So side A is over here, side B is here, side C is here. What they gave us was angle A, 40 degrees. Side B, which was 14, no units on that, and side A, which was 12. All right, so notice in this case, I have 1 angle and 2 sides, and the angle is not between the 2 sides. So side-side angle, or we never want to write that. But we knew that that's not one of the postulates for proving 2 triangles congruent, which means that not everybody, if they drew a triangle with side B 14, side A 12, and angle A 40, would get exactly the same picture. So that might cause us a little bit of a problem. And let me draw, actually I'm going to switch the picture a little bit for you to make it easier. Let me switch B and C for you. And let's make this C and this B. So there's B, which was 14, and here's C. All right, so basically think of it this way. You're trying to make a triangle. You know that you have a 40-degree angle. You know that this side has length 14. And you know the other side has length 12. But we don't know how long this side is. And so we might be able to draw 12 this way. Or maybe we could draw 12 this way. there's actually two possible triangles we could draw out of this, and so I'm not sure which one we have. So that causes us a little bit of a problem. That means that there might be two possible solutions to this. So what I'm going to do is I'm going to draw this case where the 12 went that way and 40 degrees. This was A, B is here, C is here. And then the other triangle, if AB was a little longer, we still have the 14, but this time the 12 is going to go that way. So we still have 14, 12, 40 degrees. This is A, this is B, this is C. So you can see both those triangles could be created from the information that they gave us. So does that mean we have to solve each of these triangles and we'll have two possible answers? Yes, indeed. This is called the ambiguous case. And that's because we have two sides and an angle. Or if you want to write that as angle side side. So whenever you have this situation, we have an ambiguous case. Now it gets even a little more complicated than this. Let me draw this for a second. Let's say we have here 14, 40 degrees, and let me draw an altitude straight down. That's going to be the shortest segment, as opposed to if I extend this side and going this way or this way. So that shortest segment, that's H. Right there. I can figure out what that altitude would be using right triangle trig. So let me get these out of the way. And so let me calculate that. Let's do that in, how about blue? I know that the sine of 40 degrees is equal to H over 14. And if I multiply 14 to both sides here, I will get H. And so if I grab my calculator and I type in 14 times the sine of 40, almost 9, 8.999. So let me fill that in. And what is this telling me? Well, this is telling me that if I want to draw that third side to be of length 12, I certainly could draw it in either one of these ways. On the other hand, what if they told me that side A was only 8 instead of 12? If side A was only 8, there's no way that I could get it to go from point C and actually hit side AB, because it wouldn't be long enough. And then if that were the case, then the triangle would not even exist and there's no solution. So not only do we have to figure out, oh, it's an ambiguous case, there could be two possibilities, we also have to consider whether there's actually any solution at all. And so the first thing you should always do in this case is figure out what's the height of that right triangle and make sure that that side across from the angle that they give you is bigger than that amount. In this case it is, so we're okay to move forward. All right, so let's go ahead and try and solve this. So I'll look at, let me get my arrow, let's look at this triangle right here. We'll deal with the obtuse triangle in a minute. So in that triangle, what do we have? Let me label what we're missing here. So we have B, this was B, this is A. We don't have C and we don't have two of the angles. All right, so we can't, now if you go through the possibilities, what do you want to use? Well, you're going to have to use this angle, which means you're going to have to use this side. We don't have another angle to use, so we can't use this side and try and get this angle. That would be two unknowns in my proportion, and I won't be able to solve it. So what I'm going to have to do is use this other side, and that would leave this angle for me to figure out. So I'm going to write sine of angle B over side B, which is 14, equals the sine of angle A, 40 degrees, over side A, which is 12. Notice this time I'm writing my proportion with the sign on top, not on the bottom, and that's because I'm trying to solve for the sine. It'll work the other way, it's just a little easier to solve when you do it this way. All right, so now, if I want to solve for sine of B, the first thing I need to do is multiply the 14 to the other side. And that'll be the sine of B equals whatever the calculator gives me for the right side. But I'm trying to find B, not the sine of B. So after I get that decimal on the right side, I'm going to have to do the inverse sine of whatever that answer is. Sine of 40 divided by 12 times 14. Notice I'm not writing down the decimal that I would have gotten and then do inverse sine. I'm just going to punch it all in at once. So angle B is going to equal, I should write the measure of angle B to be exact. And let's grab the calculator and take a look. I want to do the sine of 40 divided by 12 times 14, don't need that, sine of 40 divided by 12 times 14, and I get that decimal. Now I want to do the inverse sine, so I want to know the angle whose sine is equal to that. So I'm going to press second sine, and I can press second and the negative button on the bottom, and that'll say the sine, inverse sine of the last answer. So 48.58 degrees. Usually with angles, we'll round to the nearest tenth. So let's go 48.6 degrees. 48.6 degrees. So now I've got angle B. And if I have angle A and now I have angle B, I can figure out angle C by subtracting the other two from 180. I'll have to do that over here. So the measure of angle C is going to equal, since I have that angle on my calculator, let's do 180 minus that last answer, and then minus angle A, which they gave us as 40. So angle C is 91.4 degrees. And there we go. So now we've got our answers. So we have angle B, angle C, angle A. We have side A, side B. We still need side C. We need some more room, so let me get rid of this. Let's move this to the other side. There. All right, and now let's find side C. So C over the sine of angle C will equal, we're going to use A, which was 12, over the sine of A, which 40 was given to us. Now notice we're going to have to plug in our rounded decimal answer for angle C, but that's okay. So now to solve this, I'm going to multiply sine of C to the other side, and C was 91.4. And then grab the calculator, and that will give me my answer for side C. A lot to keep track of here. 12 divided by sine of 40 times sine of 91.4. I get 18.663, so to the nearest hundredth, 18.66. There were no units on this problem, so 18.66 units. So let's verify, what do we have? We were given side A, side B, we just found side C. We were given angle A, we figured out angle B and angle C. Now that was drawing it assuming our picture here. What if, on the other hand, scroll back up a little bit. We were assuming that this was the case that we had for our triangle. What if it were this case? Instead of angle B being 48.6 degrees, what would it have been over here? Well, let me draw back that altitude that we had done, that 8.99. And if the 12 units went over to there, you'll notice that this is an isosceles triangle. So this angle here equals this angle here. And therefore, this angle here in our other triangle will be supplementary to the answer we got for angle B in this step here. So, let me rewind, get rid of a lot of this. There we go. I think I got it. All right, so to find this other angle, once you find angle B, the inverse sine is always going to give you the acute angle, the angle in the first quadrant. For this case, then we're going to find the supplement of this angle, and that's what we're going to plug in here for angle B. So if I go ahead and work that out, let's switch to, how about purple? The measure of angle B is going to be 180 minus 48.6. And you grab the calculator and punch that in, and you get 31.4, 131.4, I believe, degrees for angle B. And therefore, angle C is going to be a very tiny angle now, because one of the angles is 131.4 and the other angle is 40 degrees. That's 171.4. So what does that leave angle C to be? 8.6 degrees, I think. And we can check that on the calculator, but that should be correct. So now we have angle B, angle C. The only other thing that we need to figure out is side C. And we'll do that exactly the same way as we did in the green calculation over there. So C over the sine of C, this time it's only 8.6 degrees, equals 12 over the sine of 40. We'll multiply sine of 8.6 to the other side and punch that in on the calculator, and you should get C is approximately 2.8. No units, so we leave it like that. So with this ambiguous case, you have to do a lot more work. First, you have to figure out what's the altitude length here, and is the side they gave us longer than that? And if it's not, there's no solution, and if it is, we have two possible solutions. So we start with the acute triangle case, although it wound up not being acute at the top angle. And then we try the second case, getting the supplement of that angle B. So all of a sudden, those first two examples we did seem so much easier than this example. But it all is based on what they give you. And in this case, remember, they gave us side-side angle. That was not a way of proving triangles congruent in geometry. The other two, angle, angle, side, and angle, side, angle, those were ways. So we didn't have to worry about that. So that's how you know when you need to check this ambiguous case. Let's look at one more example. This might be a great place to hit pause. Try this one on your own. All right, the measure of angle A is 78 degrees. Here's angle A. And B is somewhere down here. I'm not sure exactly where. But I know side B is 35. And side A is 28. So I don't know if it goes this way or if it goes this way. So this is an ambiguous case because they're giving me an angle and then a side and then a side. So the first thing I need to do is figure out, well, what is the shortest distance down to side AB? Let's figure out that height. And so to do that, I'm going to say the sine of angle A, which is 78 degrees, they gave it to us. Sine of 78 is equal to h, the height or the altitude, over the hypotenuse, which was 35. So I'll multiply the 35 to the other side and see what that length is. Grab the calculator, punch in 35 times sine of 78. Uh-oh. 34.2. Is the height of that triangle. There's no way that this side A could only be 28. It would never actually go all the way down and touch side AB. This way, or even if we tried to go straight down this way. Because H has to be at least, so it's got to be longer than 34.2 to actually have that side touch this side AB. So this wound up actually being easy, no solution, and then we'll just say in parentheses, not a triangle. And that's all there is to it.